If you're always in list 1 and 2, you won't have to change any of these settings unless if you do a hypothesis test before, it might change the tail. So make sure you're back on the 2-tailed test there so it adjusts your p-value for you correctly. And then go down to calculate and hit enter. And it gives you a bunch of stuff in here, and the R is clear down at the bottom. So our R is negative 0.7279. And then they're saying that the critical value doesn't use a curve. It's just a number line between -1 and 1. And what it looks for is what correlation would be significant, meaning that if I had this value in one of these tails, I'm looking for this critical value here and here, I would have reject H0 if the correlation was close enough to the tail. So it's giving me how close do I need to be to -1 or +1 to be significant. And this is the program called CVR. The only other thing I need to know there is my sample size. It's how many pairs you have. And I only had 5, so my n equals 5. I didn't give alpha, so let's use 0.05. Anytime it's not stated, use the 0.05 significance. So I'm going to go to my programs, CVR, hit enter to start the program. It asks me for my sample size, that's 5, alpha, 0.05. And what it's doing there is it's already adjusting those degrees of freedom and everything. And we're always going to do the 2-tailed situation. So it has here plus or minus 0.8783. So 0.8783 is the beginning of the right-hand shaded value, and negative 0.8783, oops, missed a 7, is over here. So negative 0.7279, it's 1, but it's saying it's not close enough. So on here I'd have do not reject the null. There's not a significant correlation between, I didn't give you context, but X and Y. All right, the t-test method, that is one that you would find your test statistic as t equals r square root of n to 1 minus r squared. And again, the bottom really should have its own set of parentheses there. Now again, if I was...
If you give us that problem on the top, we can use any three methods?
Yep. Whatever one you like. But I do have a little caveat that you only can use one of the methods. You can't mix them. So at the top, I say circle which method you're doing, and you need to stick with only that method. For instance, you don't want to ever take the correlation and compare it to a critical value of t, or take the t-test statistic and compare it to that number line. Like, you don't want to mix the methods up if you want to have one style and just do that one style. This one is probably the easiest because the p-value method is in your calculator already in that linreg t-test. So if I run that test again, so not only does it give me what this t is going to be equal to, but it also gives me all the little pieces to show you work. So if you go down to the value again at the bottom, we have negative 0.7279 for this value of r here. I'm just substituting that in. And then on the top is our degrees of freedom n minus 2. That would be matching what the degrees of freedom on the calculator say, which would be 3. So I don't even have to have an extra set of parentheses in here with 5 minus 2. Tests, and then linreg t-test. It's almost to the very bottom. And then again, list 1 and list 2, and then not equal sign for your hypothesis statement. And then on the bottom, if you go down a little bit farther, there's the r squared value. So it's already taking the negative 0.7 and squaring it for you. You don't have to worry about that negative sign, the extra value. So we have that 0.5298. And I know that has to equal, if I go back up to the top, negative 1.8387. That's my test statistic. And then right below that, it gives me a p-value. P-value is 0.1633. Oh, and I can't stress enough, I get this almost every exam. When I ask for a p-value, it better be a number between 0 and 1, because a p-value is a probability, and a probability is always a number between 0 and 1. There's a lot of times where it comes out scientific notation, like 1.5 e to the negative 4, for instance. And students will just put 1.5 and say, oh, that's bigger than alpha, and I do not reject the null. And you're like, no, e to the negative 4 made a huge difference. That means move that decimal place over to the left 4 spots. So that's actually a really tiny number, and you would have rejected the null when you're going through it. So just keep a note for yourself of that any p-value, and especially if you're using like that CDF, for instance, maybe you took the wrong tail. When you doubled it, it got a number bigger than 1. And that happened on Excel for a few of the labs where you had the idea, but you multiplied by 2 for the wrong tail. So you have to be careful with that. But anytime your p-value is bigger than alpha, in this case 16% is definitely bigger than 5%, then we would have do not reject the null. And that, right, they match. You shouldn't get different results depending on what method you're using. They should all come out to the same result. And then the other one is you find the same test statistic. That doesn't change. But you find a critical value instead. And some people just are more comfortable with one method. They just learned it that way maybe first, and they want to stick with it. And I'm okay with either of the methods. Critical value method is ancient, and you won't ever get published using a critical value method, just to let you know. So it's one of those things that's kind of been dropped since we have technology. But we would think about critical values again as the inverse, I and B something. T, right, letter T out in front, so that knows that you're going to do the inverse T distribution. Alpha is split up equally into both of the tails. So we have alpha over 2, or 0.025, in each one of those tails. And it just depends on your calculator. I think on the T89s and 83s are consistently asking for left tail area. Just be careful, because some calculator programs ask for right tail areas, so just want to make sure you're on the right one. You can do either one. If you are over here and you want to find the positive T, you would have to think of this 95% and this 2.5% all together to the left of that point, so 0.975 below this point. If you go over here, it would just be 0.025 below that point. So I usually find the negative and just know, since it's symmetric, it's plus or minus. If you're on an F distribution or chi-square distribution, you can't just do plus or minus. You got to look at both. But I'm going to go into my distribution menu, or you can go to programs. I have it on both ones. Inverse T, area. It doesn't specify what area, but it wants the left tail area. Degrees of freedom, again, is that n minus 2, so we would have 3 degrees of freedom. This is going to be the style of some of your older calculators on the 83, for instance. You just put in left tail area, comma, and the degrees of freedom. All right, negative 3.182 and positive 3.182 were my critical values. And now I'm comparing that test statistic in here. Right, negative 1.8387, not quite out in the tails, so we would have do not reject the null. Any other ones you want me to go through?
It's not a specific problem. I'm always confused when looking for critical values about when to use alpha or 1 minus alpha or alpha half, etc.
So the question is that when to use alpha, alpha divided by 2, 1 minus alpha divided by 2, and critical. There are a couple of questions where I do ask for critical values. So let's do one of the skewed distributions, because I think that one's a little bit trickier. So let's say that we have an F distribution. That was the one that was sampling 2 variances. We had that test statistic S1 squared over S2 squared, the variance of group 1 over the. If you are doing a left-tailed test, let's think about alpha is always the shaded tails when you're going through. That helps. And I think the picture will help. So my shaded tail is going to be equal to alpha. All of this area has to equal 1. It always has to add up to 1. So 1 minus alpha would be 0.95. That's how much area to the right. So this is going to depend on your settings on your calculator. So if you have a TI-89, which is confusing, it asks you for the left tail area. So we would be putting in 0.05. On the TI-83 and 84, it asks you for the right tail area.
And that's in the inverse F.
Uh-huh. We would do inverse F. So we would put in 0.95. So really, on your picture, for me, it makes a big difference. I'm trying to find this F right here that separates that lower tail and upper tail. So you might want to make it on the 83 and 84, if you're doing the inverse F, then the area that you're going to put in for a left tail test would be 1 minus alpha. If you're doing a two-tailed test, alpha has to be split up into both of those pieces. So alpha divided by 2 would be 0.025. So you still have 0.025 in each of the tails and 0.95 in the middle. But your calculator doesn't want middle, right, when you're going through. So if I'm trying to find, we have this lower F, I'll put an L, and this upper value for F. We need two F statistics. So at one point on one of the calculators, I'm going to have to use an area of alpha over 2. And on the other one, I would do it again, run the whole program over again, and do 1 minus alpha over 2, or 0.975, so that those two things add up to 1. Thinking about, if I have a different color here, maybe that would help. From that point over, I'm saying that there's the 95% in the middle and the 2.5% on the other tail, so altogether that adds up to 0.975. And then right-tailed test, it's just the flop of that.
And then is it the same basic idea for like?
Yeah, so if you're doing a T distribution and your symmetric distribution, it's exactly the same idea, but area to the left instead of area to the right, but it works the same.
So if you're doing a left tail test, then you just use alpha. If you're doing a right
That is correct. So for a
That's what's confusing, isn't it?
T test, and that's one of the reasons I put that inverse T on the program menu. So if you go into programs and then to inverse T and start that program, it asks you, it says area left of the point. So just as a reminder that one says area right, one says area left, so it'll cue in on there. So if you have a left-tailed test, your area is going to be equal to alpha. If you have a right-tailed test, so alpha 0.05 is still here, but the calculator wants how much area is to the left of that point. So you're going to want to put in your area as 1 minus alpha. And then if you're doing a two-tailed test, now this one's symmetric, so you only have to do one of them, but the lower tail is going to be alpha over 2.
And then, so for the T and Z distributions, that's the same, and then for the F and I distributions?
Yes. So this one works the same for F and the chi-squared. Same one.
It's just the calculator program, like differences though.
Yeah.
Thank you.
And then the SD inference program, that one will find you your chi-squared statistic and your p-value as well. So that's testing one variance. Let me see if I can find one like that. I don't know if I brought one like that.
Would that be the same thing as number 3 on the practice Midterm?
Probably. I just don't have that open right at the moment. So let me. Come on, let's see. Alright, actually, let's do this one. So this was pulled off of Alex.